This is video number 3 for the land use land cover discussion and change detection. So one more thing from this slide that we need to discuss. I added one more thing to cycles and trends. So we can also describe change by talking about whether it is a seasonal change or it is a long-term trend. And then of course whether or not it has human impacts on the ecosystem is one example of a long-term trend we can discuss. So these are all different ways that you can describe the change that you detect. These are important questions that should be answered in any change detection study. You can simply say there are no cycles or trends, it was one major change, right? So you can answer some of these questions simply. In other questions, you'll need to dive in deeper. Okay, so for any significant change detection of a of a subtle change, not abrupt, of some sort of a subtle change, usually 7-year is the interval that is required. That's generally speaking, that's the accepted interval to look at urban change, especially, or any type of land use change. But of course, as you know, this depends because sometimes you can have abrupt changes that would happen over a much shorter period of time. But that is a typical interval that's used. These images here are showing a 7-year change of a particular place. And you can see that these fields were developed into an urban. So there was change between classes, most likely. Here we're looking at a couple of images in Arizona, and you can see clearly how this landscape has changed dramatically over this period of 9 years, where agricultural land has been developed into urban residential, mostly over here as well. So these are some examples of change detection. You can see they've been labeled with their level 1 and level 2 land use land cover classification. Here's an example of satellite imagery, false color of Las Vegas. This is 1972, this is 1992, and in that time the population changed from 200,000 to 900,000, and that's very clearly seen with all of this urban development that expanded outward from the center. Okay, another example. Here we're looking at New Jersey. This is a land cover map in 1995 showing urban land cover. This color is mostly rural. This color is mixed landscapes, meaning rural and urban. And then this color is highly urbanized. But we could also, in 1995, create this map showing how where there's been urban growth over almost a 10-year period. And this was created looking at, oh, well, this is mostly rural in 1995, but it's in the highest growth period where there was a lot of change. Even though it's mostly rural, there was still a lot of change. So these two maps combined give you a different viewpoint. So if you just looked at this map, you would say, oh, this is rural, everything's good, you know, this, if you care about forested areas, right? But over here you see that even though it's mostly rural, it is urbanizing still. So the combination of these change detection maps really important to understanding the full story. This color, by the way, is low growth, and that is one of the highest urbanized areas, and the reason why it's low growth is because there's not a lot of room left to continue that urban growth. Here's an example of a pixel by pixel process of change detection, we're looking at an area that changed from 1986 to 1996, and looking at that land cover change. Here's the resultant image from Urdas Imagine, and the red are areas that were deforested. The orange were non-forest all along, and the green are forested. So you can see clearly areas that were forested but are no longer over this period of time. Essentially, the urban areas are spreading. And just as a side note, when you do these change detection studies in a computer application like Urdas Imagine, your photos must all be rectified. All the distortion must be eliminated. We talked about that early on in the semester. Okay, here's another example looking at South Carolina from 1982 to 1988, and some subtle changes are shown and some greater changes are shown. You can see how some of the water, for example, see right here, has been filled in, perhaps. It's one example. Okay. Here's another example. I like this one. This one is looking at a particular area in Russia, June 17th, 1989, only a few years later in 1992. So look at this sort of blue cyan colored area, aqua, really stands out, doesn't it? And you know what that color represents already. That represents bare soil. Now, in this case, if I didn't show you this already, this result, maybe you could figure it out. So the reddish brown areas are forested, and over here, a lot of that forested area is now bare soil. So what happened? Any thoughts, any ideas? Well, you might first say, well, it was probably deforested and cut down to be used. Well, that's a good guess, but if you look at the shape of this cyan area, you can see it's pretty jagged and curved. It isn't even. There's no cultural pattern to this cyan area. So that tells you perhaps it's more of a natural change, or quote unquote natural, rather than a human change or cultural change. So what actually happened here was there was forest fires, and the edges are going to result in the landscape more than a human cultural decision of where to cut down forests. So you can find clues based on shapes and patterns, right? It's very curvy. That tells you it's not cultural. Okay, here's a map that I love. This map was created actually by a friend of mine, John Hasse, and our professor, Dr. Lathrop, at the Center for Remote Sensing and Spatial Analysis at Rutgers. CRISA is the nickname. It's a great place. I think I provided you that website. Lots of great remote sensing resources at their website. But this was created looking at land use, land cover from 1972 to 1995 and creating a GIF that shows the progressive changes to New Jersey. And you could see, generally speaking, that the developed, that red increases. I mean, that's the most significant noticeable change. And then using Urdas Imagine, John was able to actually quantify how much land space was lost to urban growth. And some of it was to urban growth. The numbers don't quite measure up, so there had to be other changes besides just to urban, right? So in some cases, Wetlands might have been lost to farmland, but overall farmland was lost, right? I mean, there's complications to these numbers, but generally speaking, we saw overall urban growth of 16,000 acres per year and loss of farmland, loss of forest, and loss of wetlands overall in this period of time. Okay, I want to show you one more thing. This is the handout that's available on Blackboard. It's a PDF file, and it's from a textbook, the one I didn't make you buy, but I scanned in and provided this to you. This is let's go back to the first page. This is, move it over a little bit. I told you that I was going to share with you a level 3 system. So level 1 and level 2 are the USGS system, and then the level 3 was developed in Connecticut. On the state level. So you're going to use this particular handout to do some classification in the lab. Okay, and you also will want to have this handy during the final exam because you'll need it. Okay, so you can see here we've got level 1 urban, and then level 2 urban is really divided up into, well, this is just an example. Let's go into this. Level 1 is urban, then level 2, 11 is residential, 12 is commercial and services, 13 is industrial, 14 transportation, 17 is other, such as golf courses. Now, a different state might have put golf courses somewhere else. They might have defined this a little different. And you notice that 15 and 16 is missing here. That's because Connecticut didn't use 15 and 16. So, you know, each state can modify the USGS system based on their needs. And then their level 3 included rural, low density, medium density, high density residential. It included, for commercial, low impervious cover, medium but mostly buildings, and then high impervious cover, etc. Okay, so you can look through these, and although it won't be perfect, you're going to use this system. Okay. Oh, and notice that this continues on this page. Okay. Other includes golf courses or other urban built-up land. Agriculture, right here with level 3, like orchards. 22 is orchards, groves, vineyards, nurseries, ornamental horticulture areas, but then you can say, well, it's just an orchard, or there's a greenhouse there. So level 3 gets more specific. Okay, so I just wanted to show you that quickly. Okay, this ends the land use, land cover, and change detection video series.